Supposing I put a hot tea inside. So what will happen? The hot tea will have lot of heat here, a lot of temperature here, lot of, let's say, 100-degree temperature, and outside it's a room is 27-degree. So obviously heat will try to flow from high temperature to low temperature. Now this guy stops it. He says not allowed. How does he stop it? He allows it through three ways. One, he says I put a insulated stopper, this stopper, and this is insulated. Now why? What do you mean by this? Now, you see, if there is air inside, so this air will get hot, it will rise, and it will try to escape out of this, take the heat along with it, but this doesn't allow it. So it stops convection, reduces convection, and of conduction. How? Because even if the air will come hit it, and these particles will vibrate, these particles, but there's an insulating material. It's a very poor conductor, like cork or some wood or something like that. So it doesn't allow, because this insulation is very, so it will also protected from conduction. Then a double walled container, heat will come here, it will heat up this, but then it will want to cross this barrier. But there's a gap, there's air in between. Now air is entrapped here. So it can't convect, it can't go up and move around. And the other is a poor conductor. So air has been removed. In fact, it has is if air has been removed from here. There is no air. There is a vacuum. Yeah, I forgot about that. There is vacuum here, and the vacuum is uh, there's no air to no conduction possible. Even though no conduction to air, there's no air, so no conduction is possible, and no convection is possible. Because air, वैसे तो it's a poor conductor, but at least it can convert. But there's no air also. They create a vacuum. That's why generally these flasks they sometimes burst open because of vacuum present inside. Sometimes the glass breaks down if you don't handle it properly. And then even if, okay, so there's no conduction, no convection. What about radiation? Radiation is also not allowed. Why? Because it's a silvery surface. It's always shiny inside. So if you got two surfaces, even if this gets hot, it's a silver. So silver is a poor emitter. It's a good reflector, so it won't emit. Even if it emits a bit, this will reflect it back. So there's silvery surfaces which are poor emitters and good reflectors, so they don't allow it to go out. So we are reducing through radiation, we are reducing conduction, convection, all these. So they will might ask you a question like they have asked here, that shows a section containing a hot liquid, the surface to have shiny. So why the loss of is by conduction is very low through between the walls through, because there's no air, there's vacuum here, they've explicitly. So there will be no air particles to conduct heat, and also convection. And why through the walls by radiation is very low, because I told you these are silvered, so they don't emit. Even if they emit, some part emit, it will reflect back. And so, and what must be added to keep the hot? They haven't have a stopper here, so the stopper, insulated material stopper. This is the answer.